Ladies and gentlemen, engineers, welcome to another tutorial. My name is Dele from DevOps and Cat. Now, in case you're wondering what an AMI is, an AMI stands for Amazon Machine Image, and it's a pre-configured template containing all the information required to launch an EC2 instance or a virtual server in the AWS cloud. The AMI would contain things like the root volume, made up of the operating system, software applications, and other information required for the instance to be created. It will contain launch permissions to specify what account has the right to launch this instance, to use it. Also, to use the template. Also, it will also have information about block device mappings. So it will have information regarding what devices or what volumes need to will be attached to this instance when it's created, and also the configuration settings of these volumes. So all these things make up part of the AMI, the Amazon Machine Image. Now, there are different reasons why a company would want to have a custom AMI. Because even though we can create an AMI on the fly, by using different filters, we can even we can purchase AMIs at the Amazon Marketplace. So it's not a must to do this, but most companies would rather do that because I think the first reason is uniformity. Perhaps we have a particular way of working, and we prefer some particular software, we prefer some particular levels of security, we prefer some operating systems to others. So we can have this as a base in our images, so that it be uniform across our whole infrastructure. So every instance which we use would have those standards. That's one good reason to do that. Uniformity, standards. Number 2 is efficiency. Perhaps we use things like auto scaling, where we have our infrastructure, our servers scale out and scale in, and then so we need to create machines, on the fly to meet demand. And it makes more sense to have your pre-configured images from which the new machine will be spawned from, rather than trying to do that, from scratch or through a script. It's just better to have everything already in the image. So it allows it to be more efficient, faster, smoother, and more streamlined. Also, things like security. We can have hardened images where we incorporate all our security best practices into our image. So that way, the base image already has, it's already toughened, and it'll be more resilient and be more resistant to vulnerabilities. So the many other reasons why we could want a custom AMI. So it's a very important concept to learn. So in this video, I will show you how to create this custom AMI, and then in the part 2 of this video, another video, I will show you how to use the AMI to create an instance which will be a replica of the instance the image was created from. So get ready, grab your cup of tea, and I'll see you at the terminal. Thank you. Okay, so let's begin. We have two folders here, one to create our backend and one for our custom instance. Now on the backend, I put in the Terraform files because we want to save our state files in a remote backend in an S3 bucket and lock it with DynamoDB, with a DynamoDB table. So that's the provider details for the backend. It's AWS. And then in the backend, you will see that we create the S3 bucket. We enable versioning as well. You can see that below. That's the variable name, which we shall set in the Terraform TFVAS file. You can see on the left. There we shall allow server-side encryption, bucket versioning, and then we shall create the table of the DynamoDB table. Okay, and there we have the variables, and there we've set the variable names in there. So we shall create the backend first because we need to store our state files in this backend. So let's run Terraform init. Let's initialize our configuration. Yes, so that is, let's change directory to the correct directory, the backend directory. cd backend, that's change directory. And when we're in there, we can now run Terraform init to initialize our configuration. Yes, there it is, initializing. And then, okay, so that's been done now. Just have to wait for it. It's going. It's still initializing. Okay, that has initialized. So next, let's plan. Let's run a Terraform plan. All this is just going to create our backend first of all. Store our state files, Terraform plan. We can store our files locally. There's no need to do this, but in the real world, we want to store our state files remotely to allow collaboration. So let's just do it the right way. Okay, it's going to create 4 resources. That'll be the S3 buckets, the DynamoDB table, the versioning, and the server-side encryption. Yeah, correct. So let's apply this now, and that'll be the first part of this setup done. Terraform apply, and I just auto approve to avoid the prompt for the action. Okay, so there it is. Our backend is being created. The S3 bucket. Store our state files. Yeah, you can see it's being created there. Oh yes. And then the DynamoDB table, which I use to lock, for table locking. Table locking is important to maintain consistency, so that only one person can access the state file at the time. Okay, so for is added, first part completed. So now let's go to the console and see what has happened. So we have no instances yet, and they have not been created. Let's check. Let's go to S3 and see if our S3 bucket has been created. So far, first of all, we see no instances are running. We shall create one soon after we have created the bucket and table. So let's go to S3. Let's go to S3 now. I'm checking. Yeah, you can see the DevOps. You see, uncaught remote backend that has been created. That's our S3 bucket. So let's now go to DynamoDB and see if our table has also been created. That's the power of Terraform infrastructure as code. So let's go to .mvb. Let's go to tables. Yes, and see yes. That's one cut. Terraform locking. That's our table. So the backend is ready to go. That has been okay. So we're going to create. Now the plan is we're going to create a Jenkins server. Okay, it'll be a Jenkins server. So the server going to be going to be for our pipeline, and we need to install about 6 or 7 things, 7 different pieces of software for our pipeline. So this server is going to have all that installed into it. We shall use a user data script to install different things into it. Okay, so it's a really heavy image. So let's just go to the create custom instance. So here we've used the VPC, but I won't go into that today. VPC, we have 2 public subnets. Subnet 1 and subnet 2 public, but we shall be using public subnet 1 to create our instance today. Here now you can see we have selected S3 as our backend, Terraform backend 3, and we have mentioned, we have stated the bucket name and the DB table name. So our configuration will use the remote backend to store our state files. Okay, so now let's go into, well, let's see. Okay, that's, you can see, you understand this. So we shall store state files remotely. Now this contains the information for our instance we're creating. We shall use a data source to get an Ubuntu image. And the filters will be, we get an image that we have an HVM type for virtualization. It'll be HVM. It's going to have owners, that's AWS there. Our key pair, we shall use an existing key pair, which is why I've used this data source to retrieve it. Now, this is the resource, this is our instance. We shall call it Jenkins server. The AMI will be the data source AMI. We create, latest from the Ubuntu which data source which we did earlier above. Our subnet ID, we're going to create it in a public subnet 1, which I chose from the ones we had already. Okay, let's go on. Hope you understand that. So subnet ID is subnet public subnet 1, yes. Instance type T2 large, yeah, fairly. It will cost you to do this because we're installing a few things. The micro is too small, so I'm using T2 large today. So it might cost you a little bit. So don't forget, when you finish this, turn it off. As a public address, public IP address, true, because we need the public IP. And also now look at this, the key. The key name is now the key name of the data source retrieved by our data source above there. So you have to understand that too. Now look at this. User data is references a file called Jenkins sh. Now this Jenkins sh contains the script, the bash script that's going to install, bootstrap our Jenkins server. Okay, now we have an elastic IP for Jenkins server as well. You can see that the instance is the Jenkins server there, Jenkins server ID. We want an elastic IP so that if we switch off our Jenkins server, it will maintain the same IP address. Now this is the Jenkins script, sh, which it will reference. So we're installing, we're installing, Jenkins, then installing Git, installing Terraform, installing kubectl from Kubernetes. So on is installing Maven for Java and Java testing. Yeah, so installing Maven. It's installing Docker for containerization, and it's installing what else? SonarQube for code analysis, static code analysis. It's installing Trivy to scan our images. So you can see all this will be installed while our instance is being created. So this is why we want to use a gold image so that instances, so if we have to scale out the new instance, we also have all this installed, pre-installed, pre-configured. So that's the importance of a gold image here, because we have loads of things already need to be installed on it already. So rather than do that from scratch every single time, the image made from this instance would have all this pre-configured on it. Okay, so this user script will install all this while now. Okay, this is the security group. Now the Jenkins server needs different ports. Okay, let's initialize this first of all. We'll come back to that later. So initialize our configuration. That is, if you notice, we're in a different folder now, so it will not affect the backend. So Terraform init to initialize. It is initializing. It's checking a few things. Downloading plugins. It needs to connect to the API. So now let's run a Terraform plan. So it's going to create the whole networking, VPC, internet gateway, all that, and then it's going to create the elastic IP, the instance, and everything else. So let's Terraform plan. That's quite a lot to do. So this is a really heavy instance because we're installing about 7 different pieces of software during creation. So there you can see we're going to create a few things here. Elastic IP can be created. The instance itself, we got other things. Yes, internet gateway, route table, what about session, security groups, the group rules. Yes, for Jenkins, should I keep everything else? Now, for the security group here, we opened up port 80 for HTTP. We opened up port 9000 for SonarQube and port 8080 for Jenkins. That's in our security group. So that don't forget that in case you miss it. It's in the security group file. So to apply or to approve, let's apply. You can see the file on the left says Jenkins sg.tf. That contains the configuration, the code for the security group. Okay, so now we're creating our infrastructure. It's been created. Internet gateway is being done. Route table, VPC, route table, security group rules. Okay. The subnet 1, public subnet 2, route table association being created. Then the Jenkins server, that'll take the longest because remember it's going to install from a script the user data script, so that will take a bit of time. Okay, so apply complete, 15 added. So now we've outputted 2 things, the Jenkins elastic IP and the Jenkins public IP. We use an elastic IPs and an elastic IP for the Jenkins server so that it wouldn't change. So we shall use this Jenkins AIP instead of the public IP for all our networking. Okay, so let's copy this because we shall go to the browser and see if our Jenkins server has indeed been created and if this was all successful. Okay, so that's you can see let's scroll that down. Just make sure you understand what's going on here. If you're not sure about this, go to other videos. You will see how to create instances and everything else. Lots of videos on our YouTube group, YouTube channel, DevOps Uncut, where you could learn the basics of all these things. Now, this is the output file where we outputted the public IP and the elastic IP below there, because we need the elastic IP for viewing our creation in the browser. Well, we could get this from the AWS console, but I just like to do things programmatically. So we'll just output this. Yeah, you can see with that code above. So we can just see it in the terminal. Okay, so we'll copy the Jenkins AIP. That IP is what we'll use for everything else for viewing in the browser. Okay. So let's go to the browser. Let's paste the Jenkins AIP and we'll use a colon and port 8080. That's the Jenkins port. 8080 and enter. And let's see if our server is ready. Yes, it's ready, but you see it needs to be configured. So we need to SSH into our Jenkins server. Go to that folder, just copy it there to get the password to get into Jenkins. So I'm going to copy this. Yeah, let's copy. We'll go back to the terminal. We shall SSH secure shell into our instance, and then we shall retrieve the temporary password to unlock Jenkins. So remember, we copied the Jenkins IP 18.215.17.162. Okay. So let's use that again. Hold on a second, please. For the back. So that's, hold on. So we want to do, we want to SSH into the Jenkins server itself to retrieve the temporary password. So SSH -i. Then our key, remember it was my EC2 key pair.pem. Yes, my EC2 key pair.pem. Key pair.pem. And then it will be Ubuntu at our public IP. In this case, it will be the Jenkins Elastic IP. Ubuntu at, yes, there. So enter. That should take us straight to our we're inside our server now. So let's cut. We can cut that URL to get CAT. Cut the URL we had to retrieve from where we will retrieve our temporary password. So cat the URL there, enter. Okay, we need to use a sudo because we need to be as admin. Sudo cat the URL, enter, and there it is. That's the password we need. The temporary password we need to initially configure our Jenkins server. So let's go back, copy and go back to the browser. Go back to the browser. Hold on. Yes, and admin password. Let's put that in. That's just temporary. We'll change it as soon as it and we've continued there. Okay, install plugins. Click on that. Yeah, so installing the initial plugins Jenkins needs just to start. You can see things like Git, LDAP. Yeah. Gradle. Quite a few plugins there. Default plugins, and then we can also add some more as needed. Jenkins is a very powerful tool, powerful CI tool from continuous integration, and a very important part of building a CI/CD pipeline. Okay, so we'll just use admin for everything here because just a testing. I will destroy this. I will destroy this after this demonstration, so it doesn't matter. So admin, password admin, just temporarily admin, full name admin. Let us use admin for everything. Just for this demonstration, admin, email admin@admin.com. Something, yes, let's do this. Yes, let's save and continue. Yes, so save and finish, and then Jenkins is ready. Yes, that's it. We have successfully created a Jenkins server, and just means that we installed everything from the script. That's why it's showing. This was installed from the script, configured and all done through the script. So let's see SonarCube as well. Maybe that was also done. That's port 9000. SonarCube 9000. Yes, it's loading there. So that's SonarCube there as well. So now we have our server, or our Jenkins server has all this, has Jenkins installed, SonarCube installed, Docker installed, all that installed. Right. So let's just use admins again. Something, yes. Just make this up. Okay, that. Just temporary. All this will be destroyed after this demonstration. It doesn't matter. Updates. So yes, we have SonarCube there for SonarCube analysis in our pipeline. That's done. So now, if we need to create another instance or use a scaling group, we can create an image, an AMI, from this Jenkins server, and then we have everything already pre-configured, ready to go. Okay, so yes, let's just check. EC2, our instance should be running now, the Jenkins server. Let's just have a look at what we have there. Instances. Yes, that's Jenkins server running. It is running T2 large. Yes, it's fine. Yes, that is okay. Now let's check our AMIs. Right now we have no AMI. We have just the instance. That's the AMI is there. No AMIs in this region. No AMIs owned by me. Yes, as expected, because there are none really. Okay. So I'm going to. Okay, you can see that. So we are going to create an AMI. Okay, an AMI will be based on this server. So now that's the code for the AMI. It was AWS AMI from instance. Okay, that's the code for the AMI there. Yes, but yes, but we want to but we need to get the source instance ID, and that's going to be the previous instance. So let's change this. Hold on, it's going from the previous instance. So we need to do. Hold on a second. Yeah, so one way is we could retrieve the instance ID through WCLI. That's one way. Let's just do more there. As image ID, enter again. As the instance ID there. We could do that, or we can simply use the interpolation, just get the AWS instance ID above right from the resource itself. Right from the resource. So that's one way. That's one way we've done this. That's one way. Or this way, instance ID is just AWS instance Jenkins server.id. That will give us the same result. Yes, that will give us the same result. Just that way. Yes. So you can see because that's the name of the instance of our Jenkins server. So that ID is the ID we need. But that ID is only generated after creation. So this will get it after creation. Okay. So now we shall run this, and they should create our AMI from that AMI. Now, what happens is that when you create an AMI this way, if it's running, it will stop it, create it before it starts running again, just to ensure things consistent. So let's run Terraform for a minute, initializing the backend. that's fine. Let's Terraform plan. So now we are creating an AMI from the instance we created in the previously. So this AMI, we have, it will be a template and it will have all the instructions to create an identical server as this Jenkins server. Okay, so let's run Terraform init. Let's run Terraform init now. Auto approve. Yes. Okay. So it's doing something. It will create our AMI. This might take a little bit of time because it's a heavy AMI. It's being created. It's here. It's saying want to change. Because I've done it before. Yours will be want to add. Okay, so there it is. Apply complete. So the AMI has been created. Now we shall go to the console just to confirm that we have created this AMI from our Jenkins server. And the AMI you see there, we call Jenkins server AMI. We named it Jenkins server AMI up there. So when we go to the console, we're looking out for an AMI called Jenkins server AMI. So let us go to AMIs now. Previously there was nothing. Let's go to the AMI and see. By now we should have our AMI there, present. So if things have gone okay, we should have an AMI there. Yes, Jenkins server AMI. So that's our AMI, which was created from our Jenkins server. It will have it'll be a blueprint. It will be a template that can be used to create another server that will just be identical. Have all the configuration of a Jenkins server. Brilliant. So that has been successful. You just learned how to create an AMI from a virtual server, EC2 instance, using Terraform infrastructure as code. Okay, so in the next part, I will show you how to create an instance from this AMI. So thanks for watching, and I'll see you again for part 2 of this tutorial. Thank you. Bye-bye. It's Dilly from DevOps Uncut.